Hey there, ladies and gentlemen, boys and girls. Today, we're going to talk about isotopes. All right, so today we are focusing not on the electrons around the atom, which are involved in bonding and forming relationships with other atoms and chemical reactions. Today, we're focusing deep down inside that atom to its center in the nucleus. And in the nucleus, we find two things in this very, 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 very small space, in this very, very dense space. We find protons and neutrons. And so we're going to first start talking about, going to be focusing on that nucleus and the different factors that affect what we find on that nucleus in terms of different elements. So today we're going to talk about something called isotopes. All right? Isotopes have to do with that nucleus. The electrons are still there, but we're just focusing on the nucleus right now. All right? So we're going to talk about isotopes. All right? So have your notebooks out ready to go, and we're going to talk about different isotopes, and we're going to talk about how they are. All right. We'll talk a little bit about what the definition. I'll talk about that in a moment, but here's kind of my quick explanation. We always pretend like that there's just, when we talk about the periodic table, I'm looking at it right now, we say there's hydrogen, there's helium, there's carbon, there's lithium, there's beryllium, boron, nitrogen. The reality is, in most of these ones, there's actually different versions of each element. There are about 8 different versions of carbon. There are about 5 different versions of boron. There are 3 different versions of hydrogen. All right? And these different versions of the same element are what we call isotopes. All right? They're the same version. There are a lot of similarities. They are still the same element on the periodic table, but they just have slight differences from each other in their nucleus. All right, so the way to kind of put that in fancy terms is isotopes are atoms. So you're talking about at least two atoms that have the same element, but different masses. So let's break that down real quick about what we know about this nucleus. They are the same element, all right? What defines an element, all right, like identifies it, its ID badge, is its number of protons. Helium is an atom if an atom has 4 protons, then it's beryllium. If it has 10 protons, it's neon. If I take that as 10 protons and I remove one of them, it's not neon anymore, it's fluorine. That number of protons identifies it. So these are atoms with the same element, or basically the same number of protons. All right? 2 elements that have the same number of protons, but they have different masses. All right? Now remember, mass for an atom is the number of protons plus neutrons. That gives us that mass number. The mass is the number of protons plus neutrons. Well, I just said isotopes are the atoms of the same number of protons but a different mass, which means they have the same number of protons, but the mass is different, which means they have actually a different number of neutrons. Different number of neutrons. So I could say isotopes are 2 atoms with the same number of protons, but different number of neutrons, same element, different masses. All right. So let's do some examples of that here. All right. So let's pick a really, really easy one. The simplest atom, the most basic, is hydrogen. There are 3 isotopes of hydrogen, or 3 versions of hydrogen. All right. I need some more space than that. Sorry. So let's talk about the 3 different versions of hydrogen. All right. There are 3 different versions, and I'm going to show you the notation that we use to do this, or what we call isotope notation, the ways that we write the different versions. All right, so the way we do this, all right, we can have, there's one version called hydrogen 1. All right, now that 1 is not telling me that it's the first one. That 1 is actually the mass. In this case here, so like I said here, this number 1, that is the mass number. That is the mass, which is the number of protons plus neutrons. That is our mass. All right? So in this case here, it has a mass of 1. That's the number of protons and neutrons. So in this case here, this hydrogen has 1 proton, because all hydrogens have 1 proton. That's the atomic number, right? But in this one here, its mass is 1, is equal to 1 plus the number of neutrons. In this case, this hydrogen is just 1 proton with 0 neutrons. Another version of another isotope of hydrogen, a different version, is called hydrogen 2. Where its mass number is 2. In this one here, we still have 1 proton because it's still the same number of protons, but our mass is different. It's a 2 instead of a 1. So that's a 2. 1 proton plus what? Plus 1 equals 2. It has a different number of neutrons. So it's actually, because there's this mass, it's actually heavier. Right? This version of hydrogen is actually heavier. All right? And then we have, let's say, another version here, our third isotope. It's called hydrogen 3. All right? In hydrogen 3, we have still hydrogen, so it's still 1 proton. But our mass is the number of protons plus neutrons. In this case, there'd be 2 neutrons. Or basically 3 minus the 1 proton equals 2 neutrons. All right? Now, there's even another way to do this here. Here's some of the notation. There's another way to write it. All right? We could also write this as this hydrogen here, where we write the big capital H, and we put a 1 on the left here, and we put a 1 up here. All right? What these 2 numbers are, all right? This one right here, so this is our mass number, right? This one right here is also our mass number. It's where we put the mass number. And then this number right here is the atomic number, or the number of protons. Or the number of protons. So in this case here, if I wanted to, I need red, draw its isotope notation, the bottom number on the bottom left is the number of protons, which is 1, and its mass number, which is the number of protons and neutrons. 1 plus 1 equals 2. All right? And I can do that for the same one here. The bottom number is the number of protons. The top number is the mass, which is the number of protons and neutrons. 2 plus 1 equals 3. 3 goes up there. All right? This is what we call isotope. Both of these here, these are called isotope notation. They're just different ways to show the isotopes. Because When we're talking about the nucleus, there's actually different versions of the atom, and so we have to be more specific. Are we talking about the hydrogen with the mass of 3 AMUs? Or are we talking about the mass of a hydrogen with 1 AMU? Because there's different versions. So let's recap it real quick here, because this can be a little confusing. Isotopes are different versions of atoms. Same number of protons, same element. Different number of neutrons, different mass, and thus they weigh differently. All right? So I can either write it like this or like this. Either way. Notice that I have 3 isotopes of hydrogen, 3 versions of hydrogen. Each have the same number of protons, but a different number of neutrons. And these 2 numbers equal the mass number. Right? The mass number, in this case, 1 plus 1 is 2. So I can either write hydrogen 2, or I can put it like this with the symbol, atomic number, and then the mass for 2. All right? Getting used to this takes a little bit of time. There's different versions of all the different elements. Most elements have multiple versions of them. Some don't. Most do. At least have 2 versions. Some have many, many versions of them. All right? And we're going to practice that more and more as we go forward. Different versions of the same atom, same number of protons, different number of neutrons, which means same elements, all isotopes, but different masses. All right? Kind of keep those ringing in your head as you do this. All right, that's going to be it for this video here as we start for just kind of introducing isotopes. All right, we'll practice a little bit more of this as we go on. Otherwise, good luck, and may the science be with you.